So, in this whole evolution of money, let's talk about a very important technology contributor, that is blockchain, right? And I'll try to put it as simple as possible for you to understand what is blockchain and how does it work. Essentially, what is blockchain? Is just a chain of blocks. And what do these blocks contain and how are they linked to each other? Right? So this blocks is essentially a block of data. And what does this block contains? Like there can be a data of the transactions that is happening, that is from and to, and probably the amount, or maybe little more metadata that is there. Then also there are very two important component, that is the hash of the previous block and the hash of the current block. So let's try to understand what is hash, right? So imagine you have a block and you have the whole content inside this block. You create a hash of this block. Hash is nothing but more of a, think about like a fingerprint for the data, right? If I even change this data here, the fingerprint changes, which means I cannot tamper it. If I tamper it, the fingerprint changes, right? So in a block, we discussed it has a hash of its own and it has a reference to the previous block. So when a new block is created, it has a reference of the previous block, which is this block, right? And it already has a reference. And like that, you form a chain. Every block will have a reference to the previous hash of the previous block. Now, say for example, you go and tamper one between any block in between, right? So the moment you change anything in that block, change any data in that block, the reference to the next block is broken. That by itself invalidates the whole chain, which means all the nodes or all the miners who are actually part of this network will not accept this this broken chain at all. This by itself brings a lot of security into it, which means you cannot tamper any data that has been written in the block. Once it's written forever. So first of all, that brings in trust into the system, right? That brings in a trust where you don't have to trust any one person, but the entire network. These are network of nodes and miners who are working together who will only validate the right transaction. Any block that has a reference to the previous one is the one that has been accepted. And that's how you create the blockchain. And this by itself is very revolutionary because this blockchain is this collection of data one after the other. We call it a ledger. And now anybody can access it, so it makes it more of distributed ledger, right? So you as a person can access and see any transaction that has happened probably 2 years back. Anybody can see everybody's transaction. It's just that it's all addresses, so people don't know who is it, but they can see all the transaction and it's quite transparent on this. You don't have to rely on banks to know whether the transaction has happened. You don't have to rely on any government to know where the transaction is happening. It's all there on the blockchain, right? It's all visible to everybody. Anybody can audit it and it's all there. And that is the true power of blockchain that has brought in the whole decentralization of cryptocurrency and the whole decentralization of everything that is happening around. The revolution starts with these basic things that we talk about. To dig more deep into smart contracts and understand the significance of what smart contracts does, we have to, let's take an example, a simple example, right? Instagram or Facebook or Netflix. To build a product like Netflix, there's a lot of functions that has been coded behind it. Each function does one particular thing. For example, login is a function. When you click on watch a video or watch an episode is a function and there's logic written behind it. So streaming is a function that has been written behind it. So cohesively, when you have all these functions coming together is when you have a Netflix app, which just works beautifully, where one function goes to the other function. If you tap this, something else happens. All these things comes together. And these functions, right? And when you compare that to the whole blockchain world, this whole function is what has been written inside a smart contract. The smart contract is collection of functions. These, probably a login attempt, when I click here, what needs to be done. Those logics have been built or written inside smart contracts. And you can have a lot of smart contracts coming together to build a big solution that you want to build, right? So the whole decentralized finance we talk about, the exchanges we talk about, they run with a lot of smart contracts that come together. They work between each other to give you that experience, right? So in the traditional world, we have Facebook, Netflix, everything running these code in a very centralized way. You have AWS servers where it is being executed. You have the operating system. There'll be one operating system that is executing these things. But what happens here, right? We are talking about the whole decentralized thing. We spoke about smart contract, but how does it execute? It has to execute on the network, right? It is very decentralized way because nobody, once you have published those codes, anybody can execute that. And that's the beauty of it. That's the magic of having decentralized products, because now nobody owns it. It is the network that owns it, and network that executes it. And that's smart contracts. When we talk about the whole decentralization, we spoke about monetary thing, we spoke about Bitcoin. Another very important project out here is Ethereum. And let's take that as an example to give you a perspective about what's happening here. So Ethereum created something called as EVM, which is called Ethereum Virtual Machine, right? So we spoke about contracts. Contracts work on Ethereum. And what Ethereum does to those contracts is facilitating a virtual machine for it to execute this. In a very traditional way, we understand, if you guys know about cloud computing is exactly similar, where you have these centralized servers which come together to execute this code. Similarly, this is what Ethereum does on the blockchain, which is more decentralized, something more transparent, and something more secure, right? And it happens right there on the blockchain. So that is what Ethereum is to the whole D apps. We call it the decentralized apps. It's what cloud computing was or is to Netflix or Facebook or Google. A small brief about what is decentralized autonomous organization. It's a very difficult thing, right? Like to even imagine having an organization which is completely decentralized. So in a regular organization, in a regular company, how does it work? So you have few folks, few directors who take a decision on what is okay and what is not, who take a decision whether to do this or that, right? Imagine having a company which is of the people and on the network. It's very difficult to understand, but it's the reality, right? So that's where the whole DAO era has started. Decentralization, autonomous organization. And here you have, based on the tokens that you hold, you have voting rights to vote for decisions of this organization. It can be anybody, you and me. Anybody who owns that token can participate in this voting and can participate in this decision. And this by itself is a very revolutionary thing. We are still on the early days. There are a lot of things that is just being developed, innovated. But we love the idea because, as and when we have more complex products coming in, you need governance. And for that governance, we have already mechanisms of decentralized governance for each functions, right? And this is a very interesting topic, and we'd love to see how this pan out in a couple of years from now. So let's try to understand how a blockchain transaction happens and how you can start a transaction. So let's say your address has, say few Bitcoins. Now you want to send that to somebody else. How does that work? So the address that you have is sort of like a public key, and you have a private key for that. And private key is something that is only with you. That's something that you should never share with anybody else. So in the whole software, you create a trade, and then you sign for that trade. And to sign for that trade is where the private key is needed, right? So you use that private key saying, it's like an authorization, right? You're authorizing it, saying, hey, this is my key, it belongs to it. And I am doing this transaction from this address to, X address. And now once you're done that signing of that transaction, you broadcast that to the network. And the network we spoke about, right? The miners network who do the validation of each transaction. They'll validate this transaction and try to see, did you really have the private key for this address? Once that is all validated, it goes into the block. And once it goes into the block, it is history, right? It's part of the ledger. And that transaction is confirmed. So this is how the transaction works. And here, the most important part is how you manage the private key. Because you could be holding one Bitcoin or you could be holding millions of Bitcoins, right? And key is the only security that you have against anything that's going to happen. If the funds has to go up or go to somebody else, if you compromise your keys, you'll compromise your Bitcoin.